I would like to introduce our speaker for today's webinar, Collect, Analyze, and Move Extremely Large Datasets with AWS Snowball Edge and AWS Snowmobile. Our presenter for today is Henry Zhang. Henry Zhang is a Senior Product Manager for AWS Snowball and Amazon Glacier based in Seattle. He has been with AWS since 2013 and has over 10 years of experience building large-scale cloud services. Our subject matter experts today answering Q&A throughout the presentation include Mahadeva Navali Basavaraj, who is a software development engineer for AWS Snowball, and Vineet Gatki Hemant Kumar, also one of our software development engineers for AWS Snowball. And with that, we will now kick off today's presentation, and I'll pass the mic on to Henry.
Thank you very much, Nicole. Good morning, everyone. Welcome to the webinar today about Snowball Edge and AWS Snowmobile. My name is Henry Zhang, and I'm very excited to share the next hour with you and introduce some of the exciting features that we just launched at re:Invent. So before we dive into the Snowball Edge and Snowmobile products, I just want to want to give you the big picture of how they fit into the overall AWS storage platform. So as you can see in this picture, AWS offers customers a number of ways to run their workloads, store data, process data, and stream data. On the top, you can see that customers use a number of storage systems, anywhere from a file system, which is the Amazon EFS, to object storage, which is S3 and Glacier, to block storage, which is EBS, that works tightly with EC2. When customers run these workloads, they often couple that with a number of data migration, batch and stream processing tools that they can use from the bottom. We have 6 options here, and today we're going to focus on this one, the Snowball, Snowball Edge, and Snowmobile. So 1 year ago at re:Invent, we launched the inaugural Snowball product, which we internally call that Snowball V1. Here's a picture of the Snowball, and if you have seen it, you must be very familiar with what it looks like. You must have lifted it, probably taken a picture with it. That was our inaugural attempt to help customers move petabyte scale data in an easy way. So for those of you who recall that a couple years ago, AWS had a disk-based import system, a service where customers can send us drives to import and export data. So a couple of the things that customer really ran into from a challenge perspective is that, number one, often their drives would arrive to AWS sometimes damaged, sometimes the cable is broken, and sometimes the drives don't really perform well when it's connected to our ingest systems. And the other thing that customers really worry about is that sometimes they forget to encrypt their data. So we would receive drives that has unencrypted data, and we're very concerned that customers' data will be lost, will be handled by undesired parties, and there's data security and data leak challenges. So with these top concerns in mind, we went out to design a product that really would help customers securely migrate data fast. We're talking about moving, tens of terabytes, 50 terabytes, and things like that. And that is how we conceived the initial Snowball product. So how do we tackle these 2 challenges? From the security perspective, we ensured that all the customer data that lands on the Snowball must be encrypted. This solved a major problem where sometimes customers would forget to encrypt data. And then secondly, we built a ruggedized case which could handle 8.5 G of impact that handled all of the shipping challenges so that the drives would not arrive damaged, and will come back in a form factor that we know that has a very good performance. And the third challenge that we solved was the shipping label. Some customers found that when they had to ship us multiple drives, they had to attach the shipping labels to all of the drives. Sometimes they will attach it to the wrong drives and things like that. Sometimes the shipping label would come off. So we solved that with an e-ink label that is a Kindle built into the device. It's an intelligent label that knows where to go. We completely removed the shipping label challenge. So with Snowball V1, customers were able to move 50 terabytes in a single job, and it's very easy to use. So customers would connect to the console, they'll create a job, they'll tell us a set of S3 buckets that they would like to move data into. They will tell us their shipping address, they'll give us certain permissions to write the data, and then we will ship the Snowball to the customers. Typically it takes about a day or two. And once the Snowball arrives, customers will be able to connect to the Snowball and copy data to it. And once they fill it up, they can unplug the Snowball. The e-ink label at a point will show the AWS address, and then they can just drop it off at a UPS location. And after a couple of days, the device arrives at Amazon, and we will ingest the data into the buckets that the customers have specified previously. So very simple process, and customers love the Snowball product in the past year. So just to want to share a couple of very interesting stats. So of all the Snowball jobs that we have, customers have created, they have circled the Earth over 100 times. That's a lot of mileage to travel, and you can probably guess how much data has been sent in and out of AWS through the Snowball V1 product. Customers just love that. And we also made 63 total launches, from region launches to major features to bug fixes to transfer speed enhancements in the last year. And as of now, Snowball is available in 10 AWS regions. It's helping customers from all over the world transfer data in and out of AWS in a very efficient way. So how are customers using AWS Snowball? I want to just share a couple of the common use cases that we have seen over the last year. The first one is cloud migration. This is very common with customers who want to move data and their workloads into the cloud, but don't necessarily have the bandwidth. Before Snowball, they were kind of stuck because they didn't want to do a one-time network upgrade because they just want to move, say, a few hundred terabytes of data into the cloud and then run their workloads. So now they're able to use one or a few Snowballs, copy the data into AWS in a couple of weeks, and then be able to run data processing, analytics, big data workloads in the cloud with much higher efficiency. So this Snowball really unblocked one of the challenges that they had with data migration. On the second hand, customers also use Snowball for disaster recovery. Remember that Snowball had this export feature where they can point to an S3 bucket and say, export all the data from this bucket to a Snowball, and we would copy the data and send the Snowball device back to the customer. This again solved the challenge of not having sufficient network bandwidth for the disaster recovery from the cloud. In this case, customer can just copy the data for emergency use and have AWS deliver that to the on-premises location. They can recover their site, they can do local processing, and they don't have to upgrade their network for that use case. The third case that was popular was data center decommission. A lot of customers told us that they want to get out of their local data centers, move all into the AWS, but they just couldn't find a way to move hundreds of terabytes of data, sometimes petabytes of data, into the cloud in an efficient manner. Again, this was the case that they didn't want to upgrade network. So Snowball was able to help many customers completely get rid of their data centers, decommission their infrastructure, and run their business in the cloud with higher efficiency. Just for quick math, with an 80 terabyte Snowball, just 3 of them can help customers move 1 petabyte of data within 1 week. That's really fast. And the last use case is content distribution. In this case, customers have multiple sites, multiple business units that operate in different locations. And they want to send hundreds of terabytes from one location to the other location. However, they don't have dedicated internet between the two. So what was their solution? Customers are very creative. So from the source, they would order a couple of Snowballs for import jobs. They would copy the data, upload that into AWS, and then on the destination side, the receiver would request a couple of Snowball export jobs so that they can download the data through Snowball and then distribute the content to the destination. All of this is done without upgrading the networks. So across the board, we see customers start to think about using Snowball as a way to transfer data into S3, which they really think of as a data lake. A lot of customers use a number of AWS storage services for processing, storage, and transformation. But many customers use S3 as the foundation layer that stores all of their raw data. So over the years, customers see S3 as the data lake, and then Snowball really helps customers transfer data into this data lake where then they can start processing data, for example, in EMR, in Redshift, in database solutions, as well as other analytics platforms. So Snowball really acted as this gateway to the data lake in the cloud. So I want to highlight a couple of key Snowball features that we launched over the last year. So shortly after we launched Snowball Import, we added data export, a feature that customers find very useful for disaster recovery and occasional data restores to on-premises locations, especially for those hybrid workloads. And a couple of months after we launched the first Snowball, we increased its capacity from 50 terabytes to 80 terabytes, make it even simpler to transfer large amounts of data with fewer snowballs and higher efficiency. Then a number of customers and third-party vendors told us that they want to operate Snowball as a service for their customers. They want to build integration from their software. So we added Snowball SDK, which allowed customers to create Snowball jobs programmatically and monitor the status all programmatically. And we also added an S3 adapter, which allowed customers to copy data to the Snowball using an S3 interface. Remember, though, the S3 adapter we announced last year is a tool that needs to run on a separate server. But we improved that later on, as I will show you with Snowball Edge. We also had a lot of customers that wanted to move very large Hadoop clusters into the cloud, primarily because their clusters, their on-premises clusters have grown to a certain size, but they were running out of compute capacity as they get more data and they want to expand the cluster size. So many customers asked us for a way to import Hadoop clusters easily, and we added a direct HDFS import tool where customers can copy the cluster data into Snowball without having to stage the data. And last but not least, we work with a number of healthcare customers who want to use Snowball to transfer HIPAA-eligible data. So this is very sensitive data that has personal health information. And working through our security teams, we made Snowball the 10th HIPAA-eligible service on AWS. So now customers can transfer genomic sequences, medical images, and such. And one very popular use case is running distributed genomic sequences across multiple locations, and then sending all of that data up through Snowball into AWS for aggregate big data analytics. So a question we get often from customers is, how fast is Snowball really when it comes to transferring data? So let me give you an example. Let's take transferring 50 terabytes, for example. With a Snowball device, you can transfer 50 terabytes end-to-end in less than a week. This includes 1 or 2 days of shipping from AWS to you, probably a day to copy the data from your local source to the Snowball, and then shipping the device back to AWS, and about 1 day to ingest the data into S3. So all of that can be done within 1 week. So comparing that to traditional solutions over the internet, we have a number of, typically customers have different bandwidth, and the key thing here to remember is that you only have a finite number of bandwidth that you can dedicate to this one-off data transfer. So let's take an example of having 500 megabits of transfer speed and dedicating 50% to transfer that 50 terabytes. So in that case, it'll take you about 19 days just to transfer that data over the internet. So we're comparing 1 week to 19 days at 50 terabytes. It's not too bad. The internet-based solution is still viable at small volume. However, the picture changes once we get to larger volumes. So now we're looking at 250 terabytes of data being transferred via Snowball or through internet connections. So with Snowball, you have the ability to order multiple snowballs. So in this case, you can order 5 snowballs and get all of this done still in a week. However, with internet connection-based transfer, you're looking at approximately 95 days to do that at the same utilization and bandwidth speed. So as you can see, as your data volume grows, Snowball becomes much faster and more compelling to help data transfer. So another question that customers typically ask us is, how do you exactly transport my data securely? So I mentioned this, but I want to highlight some of the key capabilities. First of all of the data that lands on the Snowball is encrypted using 256-bit encryption. This is done with the Snowball client, which writes your data. All of the data has to be encrypted. And then you can manage keys for the encryption through the AWS Key Management Service. And we ensure that the key is never stored on the Snowball device. What does this mean? If your Snowball is stolen somehow during transit, your data is encrypted and it will never get lost. We also provide very strong chain of custody from the time the Snowball leaves AWS to the time that it comes back. Every step of the way, from shipping to arriving at your site, to on-site processing, to leaving your site, to coming back to AWS, to ingestion, you'll get notifications telling you exactly the stage that the Snowball is in. Remember also that Snowball is tamper resistant, and we built in a TPM module, a hardware module, to protect its software and internal system. Finally, every Snowball that comes back to AWS, and after we ingest your data, we go through a very stringent data erasure process that follows the NIST 800-88 media sanitization standard. So we ensure that the Snowball is sanitized and is clean for the next use. So having given you a pretty quick walkthrough of Snowball V1, I'm very excited to tell you more about the Snowball Edge, which is the next generation Snowball. So this is something we launched at reInvent 2016, and we made a bunch of changes to the Snowball device. So not only does Snowball Edge comes with larger capacity, now it has 100 terabytes of local storage. It also has onboard compute capacity that's equivalent to an EC2 M4.4 extra large instance. This means customers can now do local processing, compute and run compute workloads on the device, in addition to just storing and transferring the device. We also added a number of networking interfaces. We made the networking faster, and we improved the ruggedized form factor, and we made it rack mountable so that customers can deploy those in their data centers. Let me walk you through some of the key features of the Snowball Edge. So the first one is that we added an S3 compatible endpoint onto the device. What does that mean? Remember that with Snowball V1, you were able to use the S3 adapter, but it has to run on a separate server. With Snowball Edge, the S3 compatible endpoint resides on the device, and you can talk to the Snowball as if you're talking to S3 buckets that you own. So we support a number of S3 commands on the Snowball, including put, get, list, delete, as well as multi-part upload. So from a usage perspective, customers can now program to the Snowball using the S3 interface and then extend their application to the cloud, to your real S3 buckets in the cloud without changing code. That is very powerful. In addition to the S3 compatible interface, we realized a lot of customers have file-based workloads in their on-premises systems. And oftentimes, they want to transfer files using the file interface. And they also want to run file workloads on the Snowball Edge using the file interface. So we added the NFS interface, which supports NFS 3 and 4.1. What that means is customers can now point their existing file-based workloads directly onto Snowball Edge without having to change their code. This means that a number of your backup software that writes to file systems today can write data into Snowball and then quickly help you transfer those backups into the cloud in a very seamless manner. A third very interesting feature is that it's clustering. A lot of customers ask us for a more durable storage with Snowball Edge. So we enable clustering, which allow customers to build higher durability. To start, you need a cluster of at least 5 Snowball Edge nodes. You can scale that up as you need more capacity. And you derive about 60% of capacity utilization from your cluster. So, for example, if you have a 6-node cluster, you have a total of 600 terabytes of raw storage. With clustering, you get out of that about 360 terabytes, about 60% utilization. In the clustering mode, again, the cluster offers the same S3 compatible endpoint as well as the file interface. So now this becomes very interesting because customers can now run a cluster on premises for an extended period of time, run their object-based workloads, run their file-based workloads against a cluster directly when you don't have internet connection, and then you can gradually migrate data into the cloud from the cluster. How do you do that? All you do is retire one of the nodes from the cluster, send it back to us. We will import that data stored on that node into your S3 buckets, and then you can order a new node to join that cluster as you expand it in size. So super powerful features for long-term clustered storage pool use cases. In addition to the storage interfaces and clustering, we also added lambda functions powered by Greengrass natively on the Snowball Edge. So at launch, we support lambda functions that can be triggered by the S3 put operation. So what can you do with that? A lot of customers collect images and sensor data from remote locations, from the field, from locations where they shoot images and video production. So in this case, a customer can simply drop an S3, drop a picture onto the Snowball Edge and create a lambda function that resizes the picture, that transcode the media, the media content, and do any type of local processing on the device. And then after that, they can transfer the data into the cloud, and then they can run more compute workloads in the cloud. We also made Snowball Edge faster because we realized that a customer wants to transfer more data in a faster way. So Snowball Edge has 4x the network speed compared to Snowball V1. And then the other thing that made it faster is because of encryption. Remember earlier, the encryption is done from a client that runs on your server. Right now with Snowball Edge, the encryption is done inside the device, streamlining the whole process and improving the data transfer speeds. So the Snowball Edge really enables 2 types of capabilities. I want to highlight that with you. Number one is the same migration, data migration workload that Snowball V1 supported. You're very familiar with that. You create a job, you copy data locally, you send us the device, and then we copy that data into S3 for you. This is the same migration workload the customers have been doing for the last year. Excuse me. In addition to that, the more exciting one is the data collection and analytics workload because of the onboard compute capabilities. So in this case, we see customers collecting data using Snowball Edge in remote locations, in very harsh environments where there is no internet connection. So they will collect the data, do some local processing, and then they will send the raw data into the cloud for additional processing using the entire AWS platform. So let me just double click into that a little bit more. So think of one customer, which is the Oregon State University. So they send out these coastal missions that collect images of the sea, of marine life on a constant basis on their boats. And these boats have no internet connection. So they're using the Snowball Edge to, on these ships, to collect data locally. And once the images arrive on the Snowball Edge devices, they will do some local processing, image detection, some resizing, some transformation. And then they're going to send these images, once they collect up to the full 100 terabyte, from all of these ships into AWS. And then they're going to run a larger scale image analysis across all of these collected repositories. So they're able to achieve two goals, two critical goals with a Snowball Edge. One thing is that it allows them to collect data in a very low-cost manner, secure manner, and be able to do some processing as the data arrives on the boat. The second is that they can send the data sets into the cloud in a very quick manner and then run large data analytics across the platform. So I want to share with you how the Snowball Edge experience looks like in the console. As you can see here, there are several job types that you can invoke in the console. There's the familiar import to S3 job, the similar export from S3 job, but we've added the third job, which is the local compute and storage only job for Snowball Edge. So in this case, I'm creating a cluster with Snowball Edges, and I'm going to receive 5 snowballs for my cluster. So a lot of customers tell us that they think of Snowball Edge as a Swiss Army knife. It can really do so many things. And we're really excited to see how you come up with exciting new use cases. So just to summarize, I want to summarize some of the key capabilities that you can do with the Snowball Edge. Number one is you can collect data and process data locally. This is using the onboard compute capabilities and the lambda functions. Number two is that it can extend your data center. Think about using Snowball Edge clusters that reside in your data center in extended manner, in extended timeframes, that you can write large volumes of data into the cluster and then gradually tier data into the cloud. Oops. The third one is that the Snowball Edge can help expedite moving large data sets into the cloud. This is similar to the V1 use case. Now you can move 1 petabyte of data with 10 Snowball Edge devices in as little as a week. And last but not least, Snowball Edge provides very familiar interfaces, file interfaces, and S3 native interfaces on the device that simplifies data transfer from your local sources to the cloud. So customers are already showing us a number of very interesting use cases, so I just want to share a couple with you. Number one, I already mentioned many customers that have offline, offsite remote missions, such as data collection on boats, in deserts, spatial imagery collection, in offsite locations. They are deploying Snowball Edges to collect that data and then transfer that into the cloud. Many customers are also thinking of using Snowball Edge for IoT workloads. Think of in a manufacturing plant where there are sensors that collects machine performance and data sets as such. Now customers are thinking about deploying Snowball Edges in these environments, sending the IoT data to the Snowball Edge, doing a very quick local processing to detect any anomaly machine metrics for quick on-site improvement before they send this large metrics data set into the cloud and do analytics, so that over a month's time they can say, hey, here are the trends that I see with my machine performance across multiple facilities, and these are the improvements I'm going to make so that all of my machines can operate more efficiently. So this is really the 20% local data processing plus 80% larger scale batch processing in the cloud mode. Super exciting. And obviously, customers use Snowball Edge to tier local data sets between their on-premises, such as in hospitals, from MRI machines, CT scans. They do local image analysis and visualization, and then they tier all the raw images into the cloud for larger analysis and long-term archiving. So I want to give you a minute to think about what is your bright idea. During reInvent, we ran a Snowball Edge workshop, and the customer just loved telling us about their cool ideas. So we actually have one of the questions on what is your bright idea for using Snowball Edge. So I encourage you to take a moment and to write down your idea. And we love to see these and share that with customers. While you think about your bright Snowball Edge idea, I'm going to continue and tell you about AWS Snowmobile. So this is really the, Snowmobile is really the exabyte scale incarnation of Snowball data transfer device. Because after 1 year of running the Snowball service, some customers, some very large customers tell us that, hey, the Snowball is just not big enough. When I'm transferring, terabytes to multiple petabytes, I can use the Snowball device. But when I get to like double-digit petabytes, I'm really looking at using a very large number of Snowball devices. I can do that, but is there a way that you can help me move this even faster and more efficiently? So this is when we came up with the truck, the Snowmobile. So what is Snowmobile exactly? So Snowmobile is a 45-foot long, a secure and ruggedized data container that's pulled by a semi-truck. So a Snowmobile can contain up to 100 petabytes of storage. And then what we do is, when you order one, we will drive the Snowmobile to your site. We will hook it up to your network backbone using a very fast network switch that can transfer up to a terabit per second. And then you can copy data from multiple data sources from your on-premises to the Snowmobile, which represents itself as an NFS mount point. So this may take a couple of weeks to complete copying 100 petabytes. And once you're done, we'll drive the truck back to AWS, and we'll fill the data into the containers that you told us. It could be Amazon S3 or Amazon Glacier. Then from a cost perspective, we've priced Snowmobile at ½ cent per gigabyte per month, and that is based on the provision capacity. For example, if you want a 50 petabyte truck, we'll charge you accordingly, and then we also will charge based on how long the Snowmobile job takes end to end. And the time starts from the moment that the truck leaves AWS until the time that the ingestion of your data completes at our site. So I want to cover a couple of exciting Snowmobile features. Number one is it has very, very fast data transfer rates. So I talked about the 1 terabit per second speed, and just want to help put that into context. So if you are transferring 100 petabytes of data with the Snowmobile, you can complete that in a couple of weeks end to end. That includes us driving the truck to your site, you doing ingestion on your premises, and the truck driving back to AWS and ingesting data into S3. Obviously, we assume that you have sufficient network bandwidth to load the Snowmobile, and if you do, all of that can complete within a couple of weeks. And we compare that with, for example, a dedicated 1 gigabit connection with over 80% utilization. Using that option is going to take 20 years. So a lot of customers really feel that network-based transfer for hundreds of petabytes, it's really not viable. So they really love the Snowmobile option. Number two is Snowmobile has very strong encryption. Again, this is similar to the Snowball that all of the data is encrypted on the truck, and the keys are never stored durably on the truck. And again, you can manage these keys using the AWS key management service. The third feature is that the truck itself is ruggedized, it's durable, and very secure. Not only is there digital security, which is encryption, there's also a number of physical security on the truck container itself, including a GPS system, 24/7 surveillance, cameras, as well as an optional secure vehicle that we can arrange for during transport. So we realize that customers' very large data migration workloads can be very different. It has to do with your on-premises data center location, the floor configuration, your data sources, and things like that. So we will be happy to work with you in a one-on-one basis to customize a solution for you. Anywhere from creating a Snowball truck that fits your needs, to determining the optimal migration path from all of the data sources into the truck. So we can do all of that. We can work with all of that with you. And finally, the Snowmobile is very scalable. You can order trucks with capacity anywhere from 10 petabyte up to 100 petabyte. So one interesting thing is to determine when should I use Snowmobile versus Snowball devices. Typically, we recommend customers with 10 petabytes or less data to consider Snowball Edge devices. You can do that just as efficiently. But as you move north of 10 petabytes, Snowmobile typically becomes a more viable option because you can get that done with higher efficiency. The other thing to consider is how is your data located? Sometimes customers have 50 petabytes of data in one location. That's a perfect solution for Snowmobile. But oftentimes they have the same 50 petabytes that's distributed across, say, 5 different locations or 10 different locations. So if it's distributed and a single data location has a smaller volume, then we would recommend using Snowball Edge devices because it's more agile. So with all that said, I just want to give you a quick call to action. So for Snowmobile, please take a look at our website and engage with your AWS sales contact and to get us started. And if you're using the Snowball Edge device, you can order that in a self-service manner in the console, just as Snowball V1. So with that, we have a couple of questions in the lobby that we would like you to take a quick look at. Provide us feedback. We really appreciate your input on these questions. And while you do that, I'm going to take a look at the Q&A and address them.
Thank you, Henry, for that presentation on AWS Snowball Edge and AWS Snowmobile. And thank you all for taking the time to listen in today and for submitting some great questions. We've addressed quite a few via the Q&A pod, but we apologize in advance if we might not have been able to answer everyone's questions. We do have a log of all questions from today's webinar, and the team will work hard to respond to you all in a timely manner. If you didn't see a response today during the presentation or a response in the next few days via email, please post your questions on the AWS Snowball forum. You should see the link there, so we can get an answer to you. With the time we have left for our webinar, as Henry mentioned, he will respond live to some of the questions that have been submitted. And a quick reminder before Henry kicks off live Q&A, for all of you to please take a minute to respond to the questions that you see displayed on your screen right now. This will help us to continue to improve on your webinar experience for audiences like yourselves, and also it gives us the opportunity to take the time to learn a little bit more about all of you, our audience. And with that, I will pass the mic back to Henry to respond live to some audience questions received today.
Great. Thank you, Nicole. So first question is that if we're sending data, large public data sets that doesn't require encryption, can it be turned off to increase the transfer speed? So we actually require, for Snowball Edge and Snowmobile, we require data encryption because we want to really ensure that we protect all the customer data. So remember that encryption is very easy to set up with Amazon Key Management Service. And then once you set up the keys, we take care of all the encryption process for you. With Snowball Edge, you don't need another server to run the encryption or run the tool. It's all done on the device. And then with Snowmobile, it's all done in the truck as well. So highly, we require that, and we think that's the best practice for data security. So the next question is from John. Are there plans to support SMB in addition to NFS on the Snowball Edge? So NFS is our initial launch to supporting file systems. I think what we realize is file systems are very popular in hybrid workloads, and our goal is to really make Snowball Edge oftentimes a replacement for your file destination for local workloads. So this is the beginning of a number of file interfaces that we will launch on the device, and SMB is definitely on that roadmap. We don't have a date yet, but it is definitely one of the popular asks that we have seen from customers. Okay, so the next question, is there a theoretical or practical limit on the maximum number of Snowball Edge nodes in a cluster? Can you share any information on the bandwidth and connectivity requirements between the nodes themselves? So great question. So there is a lower bound, which is 5 nodes minimum to create a cluster. There isn't an upper bound, theoretical upper bound yet. We've seen customers use, tens and 20s of nodes, and then when you set that up, all of these nodes needs to be part of the same network. And then when you're thinking about like the node limit, realize that when you scale up to tens and 20 nodes in that range, you're talking about a multi-petabyte cluster. So that's already pretty large. So I'm very curious to learn that. What you're really concerned about, is it really the node limit, or is it the total capacity, or is it any throughput efficiency that questions you may have in the clustering mode? Okay, another question is how many copies are created in a cluster? Can we do a 5-unit cluster with 300 TB of storage and 2 backup copies? That's a great question. So as of now, we write your data in a more redundant way on the device. So the way to think about it is not necessarily with copies, but comparing that similarly to the number of nines that we typically use to describe our store services. So think about S3 and Glacier being 11 nines of durability. With Snowball Edge cluster with 5 nodes, you can achieve 5 nines of durability. So that's how we think about the durability, and then we really made it in a way that it's very easy to compare that with our existing storage services. So, and a quick answer to that, to your second question is, you currently will not be able to do a 5-node cluster with 300 terabytes and 2 backup copies, because we will allocate the replication scheme internally for you and deliver 5 nines of durability. So next question is, how is the equipment in the Snowmobile powered? Great question. So Snowmobile comes with its own power unit. Actually, so Snowmobile can come with its own power generator if needed, but it requires local power source if it's available on your site. So just from a power perspective, to run the full truck at 100 PB of capacity, it requires 350 kilowatts of power. So that's definitely one of the power is one of the things that we will discuss with you during the site survey. Will determine whether you have sufficient power on site, and if you don't, we can also provide optional generators to your site. The generators will be similar in size to the container itself. So then we have to figure out, the parking space, the weight, and all that. But all of that can be done in our site survey, which we will work with you very closely on a one-on-one basis. All right, moving on. See more questions coming in. There's a question about, is data compressed before encryption? I'm not sure if you're talking about Snowball Edge or Snowmobile. We do some compression based on the data format to increase efficiency, but we encrypt the data before it's compressed. All right, so next question. Oh, this is about the cluster upper limit. Let me just read that for a minute. So you're curious about the upper limit, and you have less than a petabyte of data, so size is not an issue, good. And it sounds like the cluster will be used, customer switching, would use customers. Okay, so you're getting into a lot of the cluster setup. I think we can take that question offline with exactly how the cluster knows communicate with themselves, the communication pattern, whether it's a ring or a daisy chain and things like that. Let's follow up on that offline. So the next question is very interesting. Is it possible to do data transfer into different regions? So I'll answer this in two ways. So for Snowball Edge, when you create a device, when you create a job, there is some affinity between the device and the source region. So for example, if you create a device from our newly launched London region, the data has to go back there because you provision a device from that region. So in that case, you are not able to use one device to transfer data to another region. However, you can use multiple devices to transfer data between regions. And then also, we offer Snowball services in Europe, and then within all of the EU countries, you're able to ship Snowball devices between these countries. So I think you're asking about regions, but I think customers also ask about country limitations. So that's also something to take into consideration. All right. So this question is from Morgan. I have a business need to actively collect, process, and store data on an aircraft in rural areas, then rapidly get that data into the cloud. About how long would it take from point of collection to cloud for a Snowball Edge device in a rural area of a certain state, for example? So great question. I'm excited to tell you actually have customers that's already testing that scenario, which is exactly collecting data from rural areas. It can be an aircraft, it could be a ship, it could be any number of missions, military missions in very remote areas. So data collection is instantaneous. It can land on the device. You can do local processing. How long it takes to get the data into the cloud depends on when you ship that device to us, right? So let's say it takes you a day to fill up the device collecting the data, and then the next day you find a drop-off location to send it to us. Once we get it will take like a day to get the device to us, and then it takes us about a day or so to ingest the data. So I'll say from end to end within less than a week. All right, so I've got an interesting question. When there is a need to process data locally, would this imply running macros or predefined stuff on the fly? Great question. So as of right now, we support lambda-based functions that can run your compute capabilities. So how you would do this is you would provision these lambda functions as you create the Snowball Edge job in the console. These will be pre-installed on the device, and then you'll be able to run them based on the pre-configured functionalities. So right now we have S3 put triggered lambda functions. You can foresee us adding more triggers for lambda functions and expanding that compute capabilities to accommodate more workloads. One thing to note that is when you run these compute workloads, it does not require internet connectivity. And then once you complete these workloads, the data can be stored in S3 format or in a file format, and then you can tier that into AWS by sending the device back to us, and your application, your processing workloads can run in the same way without changing the code on your S3 buckets, on your file system in the cloud. Okay. All right, so I think we have a couple of minutes, and I want to just pass this back on to Nicole.
What?
Yep.
Okay. And that concludes our webinar on collect, analyze, and move extremely large data sets with AWS Snowball Edge and AWS Snowmobile. Thank you all for taking time out of your day to learn more about AWS services. I'd like to extend a special thank you to our presenter, Henry Zhang, for his time and for sharing today's content as well. And a big thank you to Mahadeva Navali Basavaraj and Neet Saki Hemant Kumar for supporting the webinar today, answering all of your questions throughout the webinar. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcast@amazon.com. As always, your feedback helps improve our webinar programming. Thank you.